Before you pull into a gas station again, stop for just a moment, because the real danger doesn't begin when you squeeze the pump handle. It starts before that. Small habits, things most American drivers do on autopilot, are quietly damaging fuel systems, confusing sensors, and in some cases creating fire hazards that will never trigger a warning light on your dashboard. And the final mistake on this list can save you thousands of dollars or prevent a serious accident right there at the pump. If you care about keeping your car reliable and avoiding expensive problems most drivers never see coming, take a second to subscribe. This channel exists to protect your engine, your wallet, and your peace of mind. Stay with me until the end, because almost everyone gets this wrong without ever realizing it. Now, let's start with a mistake hidden inside a movement you make without thinking. Mistake number 15. Getting back into your car while the nozzle is still pumping. You lock the handle, step away, slide back into the driver's seat to warm up, check your phone, then step back out and grab that metal nozzle while fuel is still flowing, or has just finished flowing. Mechanically, nothing inside your fuel system changed during those few seconds. Electrically, everything did. Modern fuel dispensers in the United States are bonded and grounded. The pump, the hose, and the nozzle are all designed to safely dissipate static electricity created as fuel moves at high speed through the system. When you begin fueling and keep your hand on the nozzle, your body becomes part of that grounded path. The moment you let go, slide across synthetic seat fabric, and then return, your body builds up a static charge. You've essentially turned yourself into an ungrounded capacitor holding several thousand volts. The filler neck is exactly where gasoline vapor concentrates. Gasoline vapor has a wide, flammable range in air, and around an open filler neck, there's often a near-perfect mixture waiting for ignition from even a microscopic spark. That's why U.S. fire safety codes explicitly warn against re-entering your vehicle while refueling. When these fires happen, they escalate fast. Vapors ignite, flames race up the side of the car, and drivers instinctively yank the nozzle out, spraying burning fuel across the body panel and onto the pavement. If you absolutely must get back into your vehicle, always touch a metal part of the car away from the filler before grabbing the nozzle again. Static at the pump is one danger. The next mistake brings that danger inside your vehicle. Mistake number 14. Filling a gas can while it's sitting in the trunk or truck bed. You're buying fuel for a lawnmower, snowblower, or generator. You place the plastic fuel can in the trunk or in the bed of your pickup and start filling. It feels stable. It feels convenient. In reality, it's one of the most dangerous things people do at gas stations. Most consumer fuel containers in the U.S. are made from high-density polyethylene, an excellent electrical insulator. As fuel splashes into the container, static charge builds on both the liquid and the inner surface of the can. If the container is sitting on bare concrete or asphalt, tiny moisture paths allow that charge to slowly bleed away. But when it's sitting on carpet, a rubber cargo mat, or a plastic bed liner, the container is completely isolated from ground. Once the voltage difference becomes high enough, the spark jumps at the smallest gap, usually right at the rim of the container, where fuel vapor concentration is highest. Accident investigations involving pickup truck fires show the same pattern again and again. Plastic can, plastic bed liner, dry weather, ignition at the opening. The correct method is simple. Remove the container from the vehicle. Place it on the ground. Keep the nozzle in constant contact with the container opening for the entire fill. From fire hazards, we move to something quieter, but just as expensive. Mistake number 13. Topping off the tank after the pump clicks off. The nozzle shuts off. The tank is full, but you squeeze again to round up the dollar amount or stretch out a few extra miles. On modern U.S. spec vehicles with sealed EVAP systems and onboard refueling vapor recovery, this directly works against how the system was engineered. The charcoal canister is designed to store fuel vapor, not liquid gasoline. When the tank reaches its proper level, there's a controlled space above the fuel for vapor expansion. When you force extra fuel in after the first click, liquid backs up into the filler neck, covers the vent inlet, and gets pushed into the vent lines leading to the charcoal canister. Once that charcoal absorbs liquid fuel, it stops filtering vapor and starts behaving like a soaked sponge. Vapor flow becomes restricted, and the tank can no longer breathe correctly. The symptoms show up later: pumps constantly clicking off during refueling, fuel burping back out of the filler, strong fuel odors, and eventually a check engine light tied to evap system faults. Replacing a saturated charcoal canister, vent valve, and damaged lines at a U.S. repair shop typically costs anywhere from $300 to $900. The solution is simple. Stop at the first click. Mistake number 12. Refueling immediately after a fuel delivery. You pull into a station while the tanker truck is unloading, or just minutes after it leaves. Those massive flow rates churn the underground tanks, stirring up sediment, rust, and water that normally sit undisturbed at the bottom. Even though suction pipes are positioned above that layer, a freshly agitated tank temporarily turns the entire volume into a fine debris suspension. From your vehicle's perspective, that contamination reaches the fuel filter much sooner than expected. The fuel pump has to work harder against restriction, and any particles that slip through continue toward injector screens and spray nozzles. Spray patterns degrade, misfires become more likely, and idle quality suffers long after the fill-up. If you see a tanker truck on site or notice that the fill covers are still wet, wait 15 to 30 minutes, or come back later. Clean fuel comes from calm tanks, not turbulent ones. Mistake number 11. Routinely running the tank close to empty before refueling. You push it one more day with the gauge hovering below E and the warning light glowing. On most modern vehicles sold in the United States, the fuel pump is an electric unit mounted inside the fuel tank. It depends on gasoline not just as fuel, but as coolant, lubricant, and a steady supply at the inlet. When fuel levels drop very low, a larger portion of the pump is exposed to hot vapor instead of liquid fuel. Repeatedly driving this way overheats the pump and significantly shortens its lifespan. At low levels, the pump is also far more likely to draw in air, creating brief fuel starvation events. You experience this as hesitation, rough running, or, in some cases, sudden stalling. Fuel tanks also accumulate fine debris over time. Rust particles, dust, and microscopic rubber fragments shed from hoses and seals. When the tank is nearly empty, the pump draws fuel from the same zone where that sediment concentrates. Refueling when the tank reaches about a quarter full keeps the pump submerged, cooler, and farther away from the worst contamination. Driving on fumes deprives the pump of cooling and protection. And the next habit keeps your engine operating inside a cloud of vapor, setting the stage for problems most drivers never trace back to the gas station. Mistake number 10. Leaving the engine running while refueling. You pull up to the pump and leave the engine idling so the cabin stays cool in summer or warm in winter. From the driver's seat, it feels harmless. In reality, you're refueling with every ignition and electrical system fully energized. An idling engine means ignition coils firing thousands of times per minute. The alternator is producing current. Electric radiator fans can activate without warning. Relays and contactors open and close, sometimes creating tiny electrical arcs. The exhaust system remains hot, often positioned close to where fuel vapors can travel. Gasoline vapor is heavier than air. It doesn't simply rise and dissipate. It can drift, sink, and pool around the filler neck and underneath the vehicle. Under normal conditions, vapor concentration stays below ignition limits. But U.S. safety codes are written for the rare moment when everything aligns badly. A small spill, a gust of wind that channels vapor toward a hot surface, a fan motor or relay that arcs at exactly the wrong second. With the engine running, the evap system is also active. The purge valve may be cycling, pulling vapor from the charcoal canister into the intake. The ECU expects fuel level changes to occur only during driving and fuel consumption. Some modern vehicles can detect refueling with the engine on. Others simply see an abrupt jump in tank pressure and fuel level and become confused, corrupting learned fuel trims and system data. Turn the engine off. The cabin may be uncomfortable for a minute, but your risk in a worst-case scenario drops dramatically. A running engine confuses sensors and increases danger. The next mistake delivers degraded fuel straight into the combustion process itself. Mistake number 9. Dumping very old gasoline from a can into the tank before filling up. You find a plastic or metal fuel can that's been sitting for months in a garage or shed. Instead of disposing of it properly, you pour the entire contents into your car and then top off with fresh fuel. Fresh gasoline sold in the United States is a carefully engineered blend. Light volatile components, heavier fractions, detergents, and often ethanol, balanced to meet emissions and performance standards. Over time, especially in vented containers exposed to heat and oxygen, oxidation begins. Gum and varnish-like compounds form. The most volatile components evaporate first. Octane rating drops. Ethanol-blended fuels absorb moisture from the air. Laboratory testing shows stale gasoline can lose 3 to 4 octane points and develop measurable gum content. When you pour that entire can into your tank, especially the last few ounces where contamination is most concentrated, you send the worst portion directly into the fuel system. Modern engines are tightly calibrated around minimum octane requirements. Lower the octane significantly and the NOx sensor intervenes. The ECU pulls ignition timing. The vehicle feels weak, flat, and sluggish. Meanwhile, oxidation byproducts coat injector tips, intake valves, and pressure regulators. Old gasoline should be treated as hazardous waste and taken to municipal disposal facilities. Pouring it into your car doesn't save money. It simply spreads damage throughout the system. Old fuel is one threat. The next mistake is more subtle and far more common. Mistake number 8. Always choosing the cheapest, lowest traffic pump. You hunt for the absolute lowest price station, the off-brand location, or the lonely pump that never seems to have a line. Underground storage tanks at fuel stations accumulate water and sediment over time. In some cases, microbial growth develops at the fuel-water interface. High-volume stations constantly cycle fuel. Deliveries come in, fuel moves out quickly, and contaminants are more likely diluted or detected early. Low-volume stations and rarely used pumps may hold the same batch of fuel for much longer. During that time, dissolved water can settle and form a distinct layer. Microorganisms can grow, producing sludge. Oxidation slowly degrades fuel quality. Contaminated or degraded fuel shows up as rough idle, hesitation, and poor combustion. Fuel filters clog sooner than expected. Injectors develop distorted spray patterns. Deposits increase. In severe cases, drivers experience stalling immediately after refueling, or even a complete no-start condition. Look for stations with visible turnover, regular maintenance, and a solid reputation. A quiet pump is sometimes quiet because drivers already learned not to come back. Station contamination is a slow-burning problem, and the next mistake happens instantly, sending plastic straight into precision fuel components. Mistake number 7. Using random bottles or jugs instead of approved fuel containers. You grab whatever container happens to be nearby to carry a few gallons to a stranded vehicle or a generator. Approved fuel containers sold in the United States are made from specific plastics or metals engineered to resist gasoline solvents and limit vapor permeation. Many everyday containers are not. Thin peat water bottles, soda bottles, cheap household jugs, or unknown recycled plastics can soften, swell, or become brittle when exposed to gasoline. A container that's perfectly safe for water can begin leaching plasticizers, dyes, and microscopic fragments the moment gasoline touches it. Any particles that make it past the tank's inlet strainer continue downstream to the fuel filter. Finer debris reaches injectors and high-pressure fuel pumps. Modern direct injection systems operate with extreme precision, often at pressures exceeding 2,000 bar. The real-world consequences of contamination include prematurely clogged fuel filters, noisy and overworked fuel pumps, injector fouling, and partial blockages that distort spray patterns. Owning one certified fuel container eliminates this entire category of risk. Improvised containers introduce contamination you never see, until the damage is already done. Random containers quietly pollute the fuel. The next habit overdoses chemical help, turning a cleaner into a new problem. Mistake number 6. Using fuel additives right before filling up. You pull into the station, pour an injector cleaner or octane booster into a nearly empty tank, then blast fuel in at full pump speed. Fuel additives are designed to dilute gradually in a full tank. Pouring them into an almost empty one creates a highly concentrated mixture that gets violently agitated as fuel enters and vapor escapes during refueling. Droplets and aerosolized additive can migrate toward the EVAP vent path, slowly loading the charcoal canister with chemicals it was never designed to absorb. Heavy dosing also raises solvent concentration in the fuel, reducing lubricity and adding subtle but cumulative wear to fuel pumps over time. Additive labels match bottle size to tank capacity for a reason. One bottle is intended for one full tank, not a nearly dry one. The next mistake hides in plain sight, right on the fuel grade label. where a small shortcut creates a much larger burden on your engine. Mistake number 5. Ignoring the fuel grade label. Many drivers barely glance at octane ratings or ethanol markings. They repeatedly use cheaper regular fuel in engines calibrated for premium, or casually run high ethanol blends in vehicles never designed for them. Octane rating measures a fuel's resistance to knock. High-compression engines, turbocharged setups, and aggressively timed powertrains are engineered around a specific octane assumption. When you feed them less than required, cylinder pressures and temperatures rise and knock begins. Modern engine management systems usually prevent immediate catastrophic damage. Knock sensors detect characteristic vibrations, and the ECU responds by pulling ignition timing. To the driver, it feels subtle. No explosion, no loud pinging. Just a car that feels slightly weaker and delivers worse fuel economy. But timing changes shift where peak combustion pressure occurs. More energy exits through the exhaust instead of pushing the piston. That extra heat raises exhaust gas temperatures and places long-term thermal stress on exhaust valves, turbochargers, and catalytic converters. Over tens of thousands of miles, that heat accelerates catalyst aging and increases heat soak inside turbo center housings. Cheap fuel at the pump often turns into expensive heat downstream. Use the fuel grade specified by the manufacturer. Saving a few cents per gallon can quietly shorten the lifespan of some of the most expensive components on the vehicle. Mistake number 4. Drilling the gas cap or modifying the filler neck to fix slow filling. You get tired of the pump clicking off repeatedly. Instead of diagnosing the underlying problem, you drill a small hole in the gas cap or remove a rollover valve so fuel flows faster. At first, it feels like a win. Refueling relies on a controlled balance between incoming liquid fuel and outgoing vapor through the evap vent system and charcoal canister. When that system becomes restricted or the canister is saturated, vapor escapes too slowly and the nozzle shuts off prematurely. Bypassing the system vent's raw fuel vapor triggers leak codes and exposes the tank to moisture, dirt, and debris. The real solution is repairing a faulty vent solenoid, damaged hoses, or a failed charcoal canister, not defeating the emission system designed to protect both the fuel tank and the environment. Mistake number 3. Opening the gas cap with mud and dust packed around it. The area surrounding your fuel door is coated with dried mud, road salt, beach sand, or off-road dust. You twist the cap open anyway. The dirt ring collapses, and part of it falls straight into the filler neck. Most filler necks use a flap or restrictor plate. Larger debris may stop there, but fine sand and silt ride along with the fuel splash as the tank fills. Once inside the tank, those particles circulate with every slosh and pump cycle. Modern fuel filters are designed to trap particles measured in microns because injector tolerances are extremely tight. Many high-pressure injection systems operate with clearances under 5 microns. A single grain of road salt is roughly 100 microns. Even a 5-micron particle can damage injector internals. In the short term, the fuel filter loads faster. You may notice power loss under heavy load, hesitation during acceleration, or a noisy in-tank pump. Over the long term, abrasive particles erode pump vanes and injector components. 5 seconds wiping around the fuel cap with a rag can save hundreds of dollars in fuel system repairs and thousands in injector replacements. Dirt enters from the outside. The next habit ignores warnings coming from inside. Mistake number 2. Ignoring strange pump behavior and forcing the fill. The pump clicks off repeatedly. Flow surges, stalls, or only works if you fill extremely slowly or hold the nozzle at an awkward angle. Many drivers blame the station and respond by twisting the nozzle, feathering the trigger, or restarting the pump again and again. The automatic shutoff inside a fuel nozzle is a mechanical safety system. A small sensing port near the tip detects changes in airflow caused by liquid fuel or dense vapor. That detection interacts directly with your vehicle's evap venting. As the tank fills, air and vapor must escape through the vent system. If the charcoal canister has become saturated from years of topping off, if vent lines are kinked, or if a vent or rollover valve is sticking, pressure builds in the filler neck. That pressure triggers the nozzle to shut off early. When you continue forcing fuel in after repeated premature shutoffs, liquid gasoline is pushed into vent lines designed only for vapor. The charcoal canister relies on activated carbon that must remain dry. Once soaked with liquid fuel, it loses its ability to store vapor and can physically degrade. As venting becomes more restricted, clicking becomes more frequent, and filling gets slower and more frustrating. Always try a different pump first to rule out a faulty dispenser. If multiple pumps behave the same way, the issue is likely in your evap system. Powering through it doesn't solve the problem, it only makes the repair more expensive. And the final mistake is the smallest part with the biggest consequences. Mistake number 1. Not tightening the gas cap properly. After refueling, the cap is left cross-threaded, barely snug, or clicked only once. Under normal operation, the evap system keeps the fuel tank nearly airtight and regularly runs self-tests. The ECU uses the purge valve, vent valve, and tank pressure sensor to apply slight vacuum or pressure and monitor how well the system holds it. If pressure changes too quickly, the ECU logs an evap leak code. A loose gas cap is functionally the same as drilling a hole in a sealed system. Mechanically, a cap that doesn't seal allows fuel vapors to escape, defeating onboard refueling vapor recovery and EVAP systems designed to capture hydrocarbons. It also allows humid air, dust, and road grime to move in and out of the tank as temperatures change. Moisture condenses on cooler metal surfaces, promoting corrosion and rust flakes inside the filler neck and fuel tank. Loose gas caps trigger repeated EVAP fault codes that send owners down expensive diagnostic rabbit holes. Purge valves get replaced. Vent solenoids get swapped. Even charcoal canisters get changed before someone finally checks the cap. Tighten the gas cap slowly until it clicks at least 3 times. That sound means the seal is fully locked. You can fix every refueling habit on this list, but bad gasoline can undo all of it. Some fuel brands quietly destroy fuel pumps, injectors, and catalytic converters without setting off immediate alarms. If this video helped you avoid even one costly mistake, subscribe now and share it with someone who drives every day. And don't miss the next video, where we break down the 9 worst gasoline brands in the United States and the 4 that actually protect your engine.